Hello, this is Dr. Alberg, and I'd like to welcome you to our course, Introduction to Reinforcement Learning Motion Control. This is our first lesson, which covers the course overview. The topics are divided into four sections: introduction, bridging the gap between common PID and futuristic reinforcement learning, looking under the microscope into reinforcement learning motion control systems, and then talking about possible next steps. In the introductions, we're going to talk a little bit about motivation, why we should learn reinforcement learning motion control nowadays. We'll take a look who is doing it and why. And we look at the pyramid of values of artificial intelligence machine learning and discuss the different types of artificial machine learning technologies. When we try to bridge the gap, most of the mechatronics engineers are familiar with PID systems. They use it pretty much on most of the automation machines. However, the reinforcement learning systems is different. And we would like to take a look at the analogy between the two, and then at the difference between reinforcement and PID, such that we will know which way will make sense to bridge the gap. Then to get more insight into what reinforcement learning motion control looks like, we take a look at the typical nomenclatures like state and actions, rewards. We'll look at agents, critics, and actors. We'll take a look at neural network optimization using Bellman equation and linear programming. And then we'll see how we deploy the hundreds of neural network parameters, not like PID, which has 3 tuned parameters. These are hundreds of optimized neural network parameters into the real system hardware. We'll finish the course by taking a look at some possibilities of the next step using reinforcement learning motion control, and hopefully we'll get some value in doing that in the future. With that, I'd like to thank you for your time and listening, and I look forward to see you in our next lecture.